Information in some probability problems comes in a very complex form. In this video, we're going to learn how to use tree diagrams in order to help us calculate a conditional probability. Firstborn children have a 50% chance of being female. If the first child is a girl, then the probability that the second child is a girl is a third. If the first child is a boy, then the probability that the second child is a girl is 0.4. What is the probability that the first child is a female if the second child is a female? One way to solve problems like this are to use tree diagrams. So let's see how we can put all the information into a tree diagram. What are we given first? Firstborn children have a 50% chance of being female. So firstborn children can either be female or male. So that's going to be the first branch of our tree. So the firstborn child can either be female or the firstborn child can be male. And let's write firstborn up here. Firstborn. And that happens with each of those events happens with probability 1/2. What else are we given? If the first child is a girl, then the probability that the second child is a girl is a third. Well, if the first child is a girl, that's this branch of the tree. So, if the first child is a girl, and then the event that the second child is a girl is here, or the second child could be male. And this event here has probability 1/3. We're given that over here. So that means this one has probability 1 minus 1/3 or 2/3. What else are we given? If the first child is a boy, then the probability that the second child is a girl is 0.4. Well, if the first child is a boy, that's this branch of the tree. If the second child is a girl, that's this branch. Or the second child might be a boy, male. Let's just write second born up here. Well, back to here. This has, if the first child is a boy, then the probability that the second child is a girl is 0.4 or 4 out of 10. That means if the first child is a boy, the probability that the second child is a boy is 1 minus 4 out of 10 or 6 out of 10. So what we're interested in is what is the probability that the first child is a female if the second child is a female? So how can we write that? Well, the probability that the first child is a female, given that the second child is a female. Using our definition of conditional probability, that's the probability that the first child is female and the second child is female, divided by the probability that the second child is female. Well, where's this first event in the tree, that the first is female and the second is female? That's if you go along here. And that's just simply 1/2 times 1/3. And that's 1 out of 6. The probability that the first is female and the second is male is 1/2 times 2/3. And that's 2 out of 6. Might as well go down here. The probability that the first child is male and the second is female is 1/2 times 4 out of 10, which is 4 out of 20, or 1/5. And then this branch is 1/2 times 6 out of 10, which is 6 out of 20, or 3 out of 10. So this event, the probability that the first is female and the second is female, well, that's just 1 out of 6. Now, the denominator, the probability that the second is female, you can either end up as a second child that's female if the firstborn is either female or male. So this event, that the first is female and the second is female, has probability 1 out of 6. Or the other possibility is that the first is male and the second is female, and that has probability 1/5. And there we go, that's our probability. So now that's the same as 1 over 6 divided by 11 out of 30. That's the same as 30 out of 66, which is roughly 0.45.